Hello, welcome. Just a quick reminder before we get started. As you, I'm sure, are already aware, we had a couple assignments due yesterday. If you got those submitted, great. If you didn't quite get a chance to finish them, or maybe vocarium was being a pain in the butt, that's okay. These things happen. You can still turn them in. In fact, I would really like it if you still turned them in. So talk to us today. Let us know what the issues were holding you back from getting those submitted. If it's vocarium stuff, we can definitely get that sorted out. If you just kind of ran out of time a little bit, we can get that sorted out too. Just let us know what you need so that we can keep you on track. You're going to have another set of assignments due this Sunday for chapter 5 and 6. So it's important to get those assignments in so that we can put them behind us and keep moving forward with the material. I think that's about it. Any questions about logistics or upcoming? Whoa, what's going on? How did that happen? I didn't even notice. Any questions about logistics or other stuff before we move on to some material today? Yeah, in the back. Yeah, so unfortunately, remember last time I was fighting with technology, and so the video it wasn't great. Let me just say it. It wasn't great. So I did not post it. However, those issues have hopefully been resolved, and so I will definitely continue making and posting those videos from now on. So sorry about that. I'm actually still upset about it. I didn't get any sleep Thursday night, mostly because my baby was awake, but. Older ones. So it's possible that the video from the last time I taught this class is up there. I honestly don't remember if I did one or not for that material. It's possible. So you can check my YouTube page. I'll post a link to it on Slack once I get a chance if you want to see if it is available. But in general, I record everything that I do. So if you want to go back and find old classes, you might have some success doing that. Any other questions? I am recording this right now, for sure, so it's going to be up. Unless I screw something up again. But that's not going to happen today. Today, everything's going to go fine. Unless there are any other questions, we'll go ahead and start talking about today's material. Chapter, was it 5 that we're on? Was all about functions. So we're going to talk about functions today. For starters, what are the parts of a function definition? I want to make a function, or you want to make a function. Somebody wants to make a function. What are they going to start typing? DEF. That's the first thing to type. And when you type that in, right, Python says, "Oh, I know what that is," and it turns it purple or I don't know, whatever color you want. So DEF is just a cue to Python that says, "Hey, we're making a function." Right? Here comes a function. What's next? A name. So this is where we got a little bit of creativity. Although I would say there are some good guidelines to follow with naming functions. In fact, I like to refer to it to another language that we know pretty well, which is English. What part of speech would you expect the name of a function to be most of the time? A verb, an action. Functions do things. They perform some kind of a behavior. So I would expect in the vast majority of cases for my functions to be verbs. That's not to say that they must follow that rule, right? The computer's not going to stop you. You can call whatever you want. The computer's not going to stop you. But if you're writing a function and you're having trouble thinking up a name that is an action, that is a behavior, that is a verb, then you really should be asking yourself, is this really a function that I'm writing, or is it something else? Maybe it's just a variable. Maybe it's just something different. So just a good rule of thumb. What's next? After we have the def and the name, we have arguments. So you see this is actually next up on my list of things to discuss. What's an argument? Variables. So they feel very similar to variables, right? They feel very similar to variables. That's true. Yeah. There's another word that you might commonly hear used instead of the word argument. Parameters, actually. That wasn't the word I was thinking of, but it's a great word. Yeah. Inputs, that's the one I was thinking of. They're all, used interchangeably. If we can skip ahead for just a moment, though, there is a difference between an argument and a parameter, actually. I know a lot of people use them interchangeably. You'll hear me use them interchangeably probably as well, but there is a difference between an argument and a parameter. Does anybody understand what that difference is? Yeah?
Is it the function has parameters and you define it with the arguments that you pass into it?
The arguments are the concrete values that get passed in. So I might define parameters as x and y. Those are just placeholders for me, right? As I'm writing the function, I don't necessarily know what the values of x and y are going to be. I might have a general idea, like, these are integers, right? Or these are strings, right? But I'm not going to know what integers or what strings those are until later when I try to use the function and I provide a concrete value. Oh, the argument for this one is 7, right? That's a concrete value, specific value. All right, did we finish our function definition? What are we missing? I'm sorry? Are we done? Oh, the colon. Man, I forget that all the time too. You guys will too. I've been writing Python for years, and the colons get me still to this day. So don't be afraid to yell out at me when I forget it. Probably going to happen today even. I think that's about it. And then so after I have the definition, right, I've got all those pieces, then I can start telling it what I want my function to do. We call that the body of the function. And just like we saw with loops, Python really tries to force us to write nice looking code, right? It's going to make us indent the lines that are in the function body. That's how I know whether something's inside of a function or not, based on that indentation. Any questions about defining functions or arguments, parameters? Okay, and so defining a function by itself is all well and good, but it actually doesn't really help us all that much until later. So what's a function call then? What does it mean to call a function?
You use your function, like you write the name of it.
It's when you use it, right? A definition by itself it's like a recipe, right? Here's how you make something happen. Here's how this recipe works. Here's the instructions step by step. That recipe doesn't do me any good until I actually gather all the stuff, right? And go through and do the things that the recipe is telling me to do. That's calling our function. That is calling our function. So how do I do that? How do I call a function? What do I need to type in my code to call my functions?
The name.
The name of the function? And then what? Arguments. Pass in some values. Do I have to have arguments? No. But there is something that I do have to have when I call a function, whether I have arguments or not. Parentheses. Parentheses. So those parentheses always go there. In fact, those parentheses are a nice visual cue that you're calling a function. You're calling something like that. What is scope?
Range.
Range? I like that. Can we be a little more specific?
Range of statements.
Range of statements?
It's kind of
The lifespan of a variable. I like that definition. So if I create a variable, call it x, right? There are only certain places in my code where I can actually use that variable. And we call that the scope. The places in my code where I can see a variable is that variable's scope. So functions have scope. There are other things actually that have scope. The other thing that we've seen so far is what? That has scope. Anybody remember? We talked about it last time. I don't think we talked about scope last time, but we did talk about something last time that has scope. The loop, yeah, the for loop has scope. And so think about what that means. If I create a variable inside of a function, where can I use that variable? In the function. That's it, right? I can't use it outside of that function. I can't use it in a different function. The same thing's actually true of for loops too. If I create a variable inside of a for loop, in the loop body, I can use that variable in the loop body, but I cannot use that variable once the loop is over. It's gone. The scope is only inside of the loop. So wherever you create your variables, that defines its scope. If you're trying to use a variable and you can't use it because it's outside of the scope, then what should you try to do? You gotta make it in a wider scope. So if you created it inside of a loop, maybe you should create it outside of the loop instead. That'll give you a wider scope, right? As one possible example. How do we know where our scopes begin and end? Indentation. Indentation. I've been saying this whole time that Python's trying to get us to write nice code, and that's true, right? That's what the indentation's for. But indentation also defines scope. Lines that are indented. As soon as I indent something, whether that be for a function or a loop body, I'm creating a new scope. And any variables that I create in that scope can only be seen within that scope. We'll see other things that use scope as well as we move along. So this is not the last time we're going to see this particular topic. What's interesting is that scope allows us to do some other kind of creative or potentially confusing things as well. For example, I created this variable called x in this function. I have another function over here, but hey, I can create a variable called x in that function too. And now I've got two variables with the same name in the same program, but that's totally okay because they have no idea that the other one exists. They have no idea that there's another variable called x because they're in two totally separate scopes. Is that a good thing? Is that a bad thing? Some people might say that's really confusing. You shouldn't do that. Other people might say if x is a valid way of describing that variable, then why shouldn't I use that word to describe that variable, right? I'm being descriptive. I'm telling you what this is. And so it's good as programmers to be aware of those kinds of scoping issues. And we'll see actually probably later on some cases where scopes collide and how we can deal with that problem. But for now, it shouldn't be too much of an issue for us. Are there any questions about scope? Or calling functions for that matter before we move on? Yeah. If I could expand upon doc strings, is that when you do the triple quotes? Yeah, the triple quotes. Sure. So doc strings, so documentation actually, let's back up a second, just talk about documentation. It's one of the most important things in the world of programming. It's also the thing that nobody wants to do. Documentation is very important for somebody who's writing a set of code to explain what your code does in plain English, right? And there are various standards that people follow in terms of creating that documentation. And this is true for all languages, not just Python, but all languages have a pretty standard way of approaching documentation. So a doc string is Python's way of doing it, and basically a doc string, a good practice for doc strings is to include them at the beginning of, we would say, all non-trivial functions or methods. So if I have a very simple method that's like one line of code, all right. I might skip the doc string for that one. It's probably fairly obvious what's going on. If I have a big, long function that's doing 100 different things, I should probably drop a doc string in there and provide a description of what's going on so that somebody who's casually browsing through my code has an idea of what that method's purpose in life is without having to sift through every single line of code. You can also do things in your doc string like explain what the inputs are, especially if it's not obvious, right? Or especially if you're expecting certain data types or certain values to come in. And what's really cool, I don't think I have the ability to show this to you right now, but remind me in a few weeks, once we get out of the textbook, to maybe show this to you. There is a tool that you can use that will go through a Python program, find all of the doc strings that you put in your program, and then basically create a manual for your program. So then you can use that manual as a reference, or for somebody who doesn't know your program, right? But they might want to use it, they might want to modify it, they might want to do something with it, you can give them that manual. They can take a look and understand how your code works. That was a very long answer to your question, but hopefully got what you were looking for. Great question. Any other questions? Yes?
To further elaborate, could you explain the difference between commenting and docstring?
Oh, sure. So doc strings are, the question was, can I talk about the difference between just a regular comment and a doc string? Doc strings are specifically for documentation, which when you hear the word documentation in a computer science context means something a bit more formal. Like I'm going to create a manual, I'm going to create a web page that has a description of these things that the public can view, right? Or people who want to use my code can view to understand what's going on. Whereas a comment, I can sneak a comment in like just as a single line comment somewhere that just is meant to be a very brief explanation of, oh hey, this is how I'm accomplishing this particular thing, or this is what the next few lines of code are doing. So nobody's probably going to read your comments except yourself, actually. It's probably the biggest consumer of those smaller trivial comments. Or perhaps other programmers who are working on the project with you. Whereas your documentation could be viewed by even non-programmers who just want to get a better idea of what your program is, what it can do, if that makes sense. Doc strings are meant for public consumption. Smaller comments are meant for personal or very limited consumption. In fact, I can show you an example of doc string. I should have thought about this earlier, but very obvious example of doc string would be to pull up, for example, the Python page for turtles. Some of you may have seen this page. I think I even was looking at this last week in class, perhaps. If you scroll down here, you'll see there's a list of all the different methods that a turtle can do, and some of these we know, right? Forward, backwards, left, and right. We've seen those before. Some of them we haven't seen before, and we honestly may not get to. But if I scroll down here, eventually I'll see a list of these methods, and then a description that tells me what the method does and shows me what the parameters are. This was generated from doc strings. This is what it looks like when I take a program with very well specified doc strings and I say, hey, turn this into a manual that people can use to understand my module, my program. This is what the output looks like. So if you use doc strings in your code, it's a nice way of providing your users or other fellow programmers a way of looking at your code, understanding what's going on. And a lot of languages have similar setups to doc strings. Great questions. Any other questions? Okay. What does it mean to return something? I'm sorry? Store of value. Getting close. I'd say that's a good start. Can we be a little more specific? I heard three things.
Can you bring a value back to where the function was called from?
Bring a value back to where the function was called from? I like that definition quite a bit, actually. The result? So it's the output. Parameters are inputs. I feed those into my function so they can do their job. And then the return is the output. What's the result? Do I need to return something? No, it's not required. It's not necessary. But it's useful a lot of times. And actually, to think about why, consider our previous conversation about scope. What does it mean when I return something or when I even pass in an argument to a function? I'm taking a value from one scope and I'm transferring it over to a different scope. That's how we get around those sometimes inconvenient scoping rules of our functions, is through the input parameters and the return values. Those allow me to get values into and out of the function's scope. But it's not required. I don't have to return something. One thing that I think is sometimes confusing at first when you think about returns, right? I see people, they'll write return, they'll say, return something, and then on the next line, they'll keep writing some code and doing stuff. What's the problem? I'm sorry? Yeah, once you type that word return, you're done. That's it. So, add code after there if you want, but it's never going to happen. It's useless. That code will never execute. When you say return, you are done. That function is over. It's done. And so it's important to be careful about when you return things. For example, we've been using loops, right? Return statement in a loop. Good idea, bad idea? Bad. Why? Because it stops. Loops imply repetition. I'm going to do something over and over and over again. But return says, no, I'm done. This function is over. So if I have a return statement in a loop, what's going to happen? It's going to run that loop once. It's going to return. And then, all the other stuff that I was hoping that the loop would repeat for me is not going to happen. It's not going to happen. So that's not to say that you'll never see a return statement in a loop. We actually will, probably very soon. But you just need to be careful. You need to be careful about it. Question? Great question. Is it possible for a function to return more than one value? Does anybody know? So that's sort of the workaround, right? The answer is no. I can return one thing. But in the future, we'll see some concepts that allow us to return one thing that contains multiple things inside of it. So we're going to see some containers, one of which is a list. We haven't gotten there yet. We'll actually also see objects. I can return objects, which can have multiple values inside of them. We haven't quite gotten there yet either. But the technical answer to your question is I can only return one thing, period. But there are ways around that restriction. Great question. Could I have more than one return statement in a function? Yeah, it's possible. Again, specific circumstances. There are certain other things that I would expect to happen if I was going to do that. But it is possible. So I could have 0 return statements. I don't need to have one. Or I could have 1 or more return statements inside of a single function. Great. Any other questions?
If you have a return inside of a for loop, inside of a function, does it break the for loop or does it return from the whole function?
The question was if I have a return inside of a for loop inside of a function. I'm not sure. So I can't define a new function inside of a loop.
No, for loops inside the function. You just said
For loops inside of the function.
and then inside your for loop you have a return.
Return. So that ends the
whole function or
that ends the whole function. Yep. Whole function's over. What's the main function used for? It's a very specific, very special function. Yeah.
It's kind of like the main body of your program. So you're going to kind of write top to bottom what you want your program to do, but within that, you're going to call out your different functions that you've defined or different things
Sure.
while it's going down.
The main body of your function? Sure, yeah. I like that. There's another term I would use to describe it. Yeah.
Organize your statements.
Organizers. So it does help with organization, right? I think there's another very important purpose of the main function.
Does it get your function started? Does it process?
Yeah, that's where we begin. That's where we begin. If I hand you a page full of functions, right, and say, here you go, run this program, you're going to look at me and be like, well, which one should I do first? Where do you want me to start? Main. That's where we start. That's where our function begins. And we may break this rule a little bit in the next week or so, but eventually I hope to get to the point where our main function isn't doing a whole lot. The purpose of main is sort of like the control panel of your program. It's not meant to do a lot of the heavy lifting. Main is supposed to call some other functions and let them all do the work and then just kind of stay out of the way, right? It's not meant to do a whole lot of the work itself. But it is the starting point of the program. And that's a very common programming concept. Yes?
Do you always have to have define a main function?
Great question. The answer is no. In Python, the answer is no. You do not have to have a main function. It is not required. In fact, none of the programs that we've written up until today have had a main function in them. We certainly haven't written them anyway. I don't know if the textbook snuck a couple main functions in there in some of the exercises. I don't think that it did. Maybe it did, but we have not used that before today. So it's not required, but there are certain situations in which it is very useful. Especially, so when do you really want to have a main function is if you think you're going to package up your program and publish it. Maybe put it out on the internet so that other people can use it.
So we really don't need to use the main function? Is that what you're saying?
There are situations in which you will need to use the main function. And we will actually see those specific situations in the next few weeks. But for the exercises that we have been doing, technically, no, you do not need a main function. It is not required. But there are situations in which it would be.
One more question.
Yeah, what's up?
On the if main,
Uh-huh.
main, do you have to use that now at this point of programming that we're doing?
It's like the main function itself, not technically required, but if you are using a main function, then yes, that part is required. The if def main equals, yeah. You're basically telling, that line of code is telling Python what your starting point is. So what that really means, if you think about it, is that main doesn't have to be the starting point of my program. I could make any function that I want be the starting point of my program. However, in practice, main is the starting point of your program. If you write a program where the starting function is not main, if you change that definition to say anything other than main, you're going to get some funny looks. People are going to look at you weird. Like, what are you doing? It's just an accepted practice at this point. Great questions. Any other questions? Okay, what is composition? I'm sorry, I couldn't quite hear you. A function calling within another function? So I'm taking a behavior and I'm breaking it down into other behaviors, right? I like to talk about composition because it really, I think, illustrates what functions are useful for. If I write a function, my hope is that I'm going to use it, and actually my hope is I'm going to use it multiple times. That's when I think we really see how functions are useful. Because consider the alternative. How could I also get the same thing across? Well, I could just write out the lines of code every single time I wanted to do that thing, right? Forget about functions. Pretend they don't exist for a second. I can kind of get the same behavior. I would just be copy-pasting the same code over and over and over again every time I wanted to do it, right? Functions allow us to write that code once and reuse that code as many times as we want, which makes our lives a lot easier. Consider what happens if I make a mistake or that behavior just needs to change for some reason. I now no longer have to find all the places where I copy-pasted it and make that change every single time. It's all in one place. It's in the function. I can just find that function and change it there, and now everywhere that I use that function, it's automatically going to detect that change. So this idea of composition, of taking things and breaking them down into smaller pieces, is a very important programming concept. And it's one that we actually use in our regular lives as well. I already used the example of a recipe, but it's such a great example, right? What are some common cooking tasks? We know how to heat things up. We know how to mix things together. Those are functions, right? What am I heating up? Well, it depends what I'm making. Maybe I'm making soup today. Maybe I'm baking a batch of brownies. I don't know. But I know how to apply heat to things. That's a function. And I can take the things that are different and use that to inform me how I should heat things up. Or mix things together. Or things like that. So a recipe is really just a composition of activities that we know how to do applied to a specific set of ingredients. I hope I didn't just ruin cooking for all of you. I actually love cooking, one of my favorite things to do, but I think about computer science every time I do it. It drives my wife crazy, but it's true. And so we're going to see that in our programs as well. Think about what that means. If you ever run into a situation where you find yourself copy-pasting the same chunk of code multiple times, you should stop, please, and think to yourself, I should make a function out of this instead, and then just use that function in the place where I was going to copy-paste this code. It's going to make your life easier. It's going to make my life easier too, because you're going to have less code for me to look at when I try to help you fix stuff. Right? And last but certainly not least, what's the accumulator pattern? What does that tell us to do? So what are the pieces that are involved with the accumulator pattern? What do I need? If I was looking at a recipe for the accumulator pattern, what would the ingredients be? I need some kind of a counter or a variable. We would actually maybe call that the accumulator variable, right? And then what? So I initialize that variable to some starting value, and then I have a loop that's going to go through, and inside of that loop, what's going to happen? I'm going to increment the accumulator, or it doesn't even have to be increment. I can just add stuff, and I can subtract stuff, I can multiply stuff. It doesn't actually matter what the arithmetic is. I'm going to apply some arithmetic operation to that accumulator variable inside of the loop. It's used often for counting things, right? I want to count stuff, so I'll run a loop and just count up by 1 every single time on my accumulator. It can also be used to do things like, compute the sum of a whole bunch of numbers, right? Things like that. It's a very common programming pattern, and what we're trying to do, the goal of introducing this pattern now, is to get you to think that, well, okay, programming is really about taking the tools in your toolbox and applying them to the situations that you're trying to solve. It's not, it's very easy to have a narrow vision of programming and think, I'm just trying to solve this problem and I'm going to solve it however I can possibly get there and be done with it and move on to the next thing. Whereas really, we have a lot of tools in our toolbox. We're adding more tools like loops, like functions. Now we have patterns that are in our toolbox. So when I look at a problem, I can say, what are the tools that I have available to me that seem like they're going to fit this particular problem? Oh, I'm doing a repeated sum. That sounds like the accumulator pattern. You don't have to sit there and bang your head against the wall to figure out how to do that. You know what the pattern is. You just set it up and you tweak it to make it fit your situation. That's programming. Honestly, I can say with relative certainty that nobody in this room, myself included, is going to necessarily reinvent the wheel, right? We're not going to come up with some mind-blowing program that the world has never seen before in the next 20 weeks, probably. But what we are going to be able to do is figure out how to apply these tools at our disposal to solve problems, and that's programming. That really is what programming is. Taking well-established patterns, well-established tools, and using them to solve specific problems. Are there questions about that? All right, let's put them to work then and do the walkthrough. I'm going to switch over here. So you can see I've already deleted the walkthrough code. That shouldn't be surprising to you. Let me see if I can full screen this real quick. Make it a little bigger. Perfect. All right. So the studio is called Wagon Wheel. That's what you guys are going to do. But I'm going to do a quick walkthrough that has us drawing stars. And so by stars, they're not very fancy stars. They're just a set of lines. But I want to be careful. I want to write a program that's going to allow me to specify, how many lines each star consists of. I want it to be a more general program. I could very easily write a program that makes a turtle and just draws, like 5 lines, right? Wouldn't be difficult. But what if I wanted to have a star with 10 lines or 20 lines or however many lines I wanted? I want to make a program that can handle all of those situations. So the idea here is to think about what's the process to create stars. And we're going to, of course, use functions to help us out here. I know some of you are probably looking at the solution right now. Stop it. Because we're going to write our own solution. And I'll be honest with you, I'm hoping that our solution doesn't look exactly like the one that's in the book, because there is almost always going to be more than one way to solve these problems. So it's good to get a different view, different perspective on a particular problem. I've only got one line of code right now, import turtle. That was, it's pretty much a gimme. Not a huge surprise that we're going to need turtles to solve this problem since we're drawing things. But the question I have now is, what else do we need to solve this problem? And actually, I'm not going to write code right now. I'm going to do something called pseudocode, where I write out what I want to do in English in the comments, and then go back and turn it into actual code. This is a very common way of approaching a problem. So I'd like to think about how we can do that for this particular problem. So I want to draw a star. What are the pieces of that star that I need to worry about?
You define a screen.
Lines? So I need lines, right? I definitely need lines. That's what my star consists of. I have a bunch of them, but I don't necessarily know how many I'm going to need. I want the user to tell me, right? Or I want to have some way to change the number of lines, right? So anytime that you have a variable like that, it's really just kind of screaming function to me right now. It's really just screaming that I need at least one function to make this happen. And so I'm going to have a function, make a function that, what? Takes in a number of lines and draws a star. I just use a plain old line comment, right? No doc strings. Actually, if you're going to use do doc strings, that's probably the last thing you would do, right? Get your program running the way you want it to, and then go back, explain what you want to happen. So I'm going to make a function that takes in a number of lines and draws a star. Now, there's another part of this that I feel like we could leverage as well to make our lives easier. I know how to draw lines. I'm going to have to draw a bunch of them. It would be nice to have an easy way to do this. Or in other words, it would be nice to take the act of drawing a line and kind of abstract it out of the process. Have a general way of drawing whatever line that I want, and then just do that process over and over and over again until I have the star that I desire. So I think that's a second function. I'm just going to go ahead and throw that out there. Make another function that draws lines. That's it. That's all it does. It just draws, actually, let's be more specific, that draws a line, period. One line. It's going to draw one line on the screen. And I hope you can already see that we have a little bit of composition going on here. Right? I've got a function that's going to take in the number of lines that I want and draw a star. And I've got another function that all it does is draw lines. So somewhere these functions are going to have to connect with each other. That's composition. That's composition. All right, let's dive in a little bit deeper to each of these now and think about what needs to happen. For every function, I need to think about name. That's maybe a little bit trivial. But what's the other piece of a function that's worth discussing? Another major piece of a function definition? Parameters. Let's think about what the parameters might be. What's going to change? If I want to draw a line, or actually a bunch of lines, what's the difference between this line and this line? What's the difference? The angle. So, right? What angle is that line going to be drawn at? So I'm going to make a comment here for inputs. Angle. Anything else? The length. How long is the line? Anything else? Where does it start? Sure, where does it start? Now, let's think about that for a second. It's a very valid point. For this particular exercise, I would argue that that might be a little trivial for us because they're all basically going to intersect at the middle. So the origin, where they start, is going to be the same for all of these. If you ever have something that's the same, that's not an input. That's just part of your function body, perhaps. But if you expect that that value might be different, maybe I don't want to draw lines that all intersect. I want to draw whatever line I want, anywhere I want. Then that would be a very valid input. Anything else?
What direction?
What direction? I believe that's the angle, would be the direction. Name of the turtle. So I need a turtle to draw a line, right? I need a turtle to draw a line. So turtle. Which turtle is going to draw this line for me? Anything else? I'm sorry? I was hoping somebody would say color. Yeah. They don't have to all be the same color. They could be. They could be all the same color, but they don't have to be. Right? Okay. And now that I've decided on the inputs, right, I can start to write in English what I want this function to do for me. So what's the first step? If I want to draw this line with the information that I have available to me, what's the first thing that I need to do? In English. In English. Rotate the turtle. All right. Rotate turtle. Then what? Move the turtle. How far, though? Length. Now we have to be a little bit careful. We'll roll with it for now. All right, so I move the turtle a certain length. I think we actually skipped a step. Should probably do the color first, right? If I'm going to change the color, I should probably change the color before I move the turtle so that it's drawing in the color that I want. So let's do that first. Change turtle color. Move the turtle. Length. That's good enough. You may have some issues with this, what I've written. I might have some issues with it. I'm not going to tell you, but we're going to roll with it for now and see what happens. In fact, I'm not even going to worry about this other one right now. I'm going to forget about that. Let's just get this function up and running, make sure that it works, and then we'll come back and try and deal with this other one. So now we're ready to go back and start turning our comments into code. So I need to define a function. Now we can start talking in code. I know a lot of you have been trying to shout at me in code. Anyway, I've been forcing you to speak in English, but let's talk in code now. Def, and then I need to specify a name. So I'll say draw line. And now I need to provide inputs. Well, I have angle, length, turtle, and color. This part's easy now, right? That's the whole point of doing pseudocode, is that it makes certain parts of the actual coding process easier. You've already spelled it out. You already know what you need. You don't have to worry about it. Just stick it in there. Okay? Colon. Oh. All right. Step 1 is to rotate the turtle. How do I do that? Create the turtle first. So I just had a suggestion to create the turtle first. I actually am very glad you said that. Do I need to create a turtle? Why not? I'm taking it in as a parameter, and by doing that, I am implicitly saying that this turtle already exists. You better already have a turtle that you can give to me before you try using this function, because I'm not making you a turtle, right? You're going to make your own turtle, and then I'll run the function to draw the line. So I don't need to make a turtle. I need to rotate the turtle. So let's do that next. Turtle dot. I mean, it doesn't really matter left or right, right? Doesn't matter a whole lot. So we'll just say left angle. Change the turtle color. How do I do that? I honestly forgot. I forgot how to change the... We can look it up. I have the page open right here. Let's take a look. What can I do? Color control. Oh, hey, here we go. It's probably one of these, color. Okay, and then I just pass in the name of the color. Okay. turtle.color, color. Now by doing this, notice too, we're also making assumptions about these parameters as well, right? Angle must be what type? An int, probably. Color must be a string, probably, right? So we're making assumptions about what those should be. And now move turtle length. That's just what? Turtle dot forward. Okay, and let's try it. Let's just try it and see what happens. Did I screw something up? We haven't called the function. So if I hit run right now, what's going to happen? Nothing. It ran the code. It looked at my function and said, oh, that's a function. And then it's done. I need to call it. I need to call it. So we need to specify arguments for each one of these. And I'm just testing it right now, right? This is just to see if it's doing what I want it to do. Okay, so then I need to call the function. So I say draw a line. And now I need to start passing in values. So I don't know, let's just pick, when I'm testing something, especially for the first time, I try to pick values that are going to be pretty straightforward. Like I don't want to pick anything crazy. I want to pick something that will be very easy for me to check to see if it's working right. So putting in pi here is probably a terrible idea for the angle, right? Keep it simple. Do 90 degrees, something that is very straightforward. For the length, you know, maybe 100. Turtle, what am I going to put in here? I have to create a turtle, so I should probably do that first, right? Okay, let's do that. Turtle equals, how do I create a turtle? I'm sorry? Turtle dot capital T turtle. There we go. And now I can put that turtle in here, right? Turtle might be a bad name, actually. So I'll name it after myself. And then finally, I need to pick a color. And remember, we said that this is going to be a string, right? So I'll say red. You can choose different values if you want. You don't have to do exactly what I'm doing if you're following along with me. We're just testing this function to see if it does what I want it to do. So, all right, let's hit run now and see what happens. I got a screen. It's red. I don't see a line. Did I put the turtle in? I did, yeah. Uh-oh. Forward takes exactly one positional argument. Whoops. What did I do wrong? I didn't put the length in here. Somebody probably yelled at me to do that, and I just didn't hear them. All right, but that's okay. That's all right. These things happen. We looked at the message, we figured out what was going on, and now we can try it again. Hey, there we go. I got a line. All right, let's change the angle and see if that does what I want it to do. 45. Hey, that looks like a 45-degree angle to me, right? We have a function that draws a line. That's great. That's great. Now let's shift our attention back to this other function that's going to take in the number of lines that we want and draw a star. How am I doing? Oh, I'm doing great on time. All right. What should the inputs be? It says right in the comment that I wrote, right? Input is the number of lines. So I guess we can just go ahead and start. Or maybe we should pseudocode this up. I'm getting ahead of myself. What am I going to need to pull this off inside of this function? What's the body of this function going to look like? What do I need? What coding constructs? I'm going to need a loop. Why? I'm repeating, right? I'm drawing a whole bunch of lines. I'm drawing a whole bunch of lines. So for what? For each line to be drawn? Maybe? Question mark? I mean, that seems okay. And then what do I want to happen inside of this loop? I need to draw the line. But remember, drawing a line requires a certain set of information, right? It requires an angle, a length, a turtle, and a color. Of those, one of those values is actually something that we kind of need to do a little bit more work on. Which one? The angle. I need to think about the angle a little bit, right? I'm drawing a star. I need to actually compute what the angles of each of those lines is going to be. So it's going to require a little bit of arithmetic. There's more than one way you can get there. 360 divided by the number of lines could be a good starting point for us. But then I need to actually, that's how much it's going to change from line to line, right? This actually, to me, feels like it could be a good use of the accumulator pattern, I think, right? So I'm going to make a variable for my angle. And then as I go through the loop, I'll update that angle variable so that it moves the appropriate amount at each time I draw the line. Does that make sense? So what should my angle start at? What's a natural point for starting angle? 0. You could pick any number you want. It's not really going to matter, right? But 0 is as good as any. So start at angle 0. For each line to be drawn, I'm going to draw the line for a given angle, length, turtle. And then color, I mean, we can just make it all one color, I suppose, if we want to. That might be an area where we can experiment around a little bit with if we have some extra time at the end. But then I need to update my angle. So how do I update my angle to make sure that it's going to do the correct thing the next time around? I need to take the angle and add something to it, but the question is what? What am I adding to the angle to get to the next angle that I'm at? 360 divided by the number of lines, right? Angle, whoops. Angle, I'm sorry, add 360 over lines to angle. Okay? This seems reasonable. Is it going to work? I don't know. We got to write the code, and then we'll find out. But this seems reasonable. So let's do it. Let's make it happen. I'm going to go back and start filling in the code for my comments. So I'm going to make a function. I'll call it draw star this time. And I've just got the one input value that we've talked about, which is the number of lines. All right, I'm going to start my angle at 0. That's not a difficult thing to do, right? Angle equals 0. For each line to be drawn, so how do I do that? A little review of last week. For loop, where I say what? For I in range lines. That'll work. Simple for loop. Draw the line for the given angle, length, turtle, and color. Okay, so this is where I do what? I call my function. Draw line, angle, that's my variable. Do I have a length? No. For now, I can just put in a number, right? Do I have a turtle? Do I have a turtle? Yes and no. Yes and no. I got this turtle down here. Can I use that?
You add a parameter.
If I add a parameter into the draw star, I could. I could. Or this code was just to test the draw line function, right? I never intended this to actually remain here. I just did this to do a test. So, take the line of code that's relevant to me, and let's just add this line. Let's create the turtle here instead. Now I have a turtle, right, that I can use. I changed the scope of this turtle to be where I needed it to be, which is inside of the draw star function. Does that make sense? This is where I really needed the turtle, so I moved it. All right, and now I have a turtle. And then the color, again, we'll just make it, no, green doesn't show up on this projector very well, so I'll just stick with red since it's a little easier to see, hopefully. All right, and then last, but certainly not least, I need to update my accumulator variable, the angle, right? Angle. How do I do this? Equals angle plus 360 over lines. If we were in math class right now, this statement would feel very wrong, right? Because equals in computer programming does not mean equality. It means variable assignment, right? So that's an okay thing to say. Any questions about what we've done? Yes?
I have a question. So inside of this function, you're defining like a specific turtle, a specific color, a specific length.
Yep.
If instead of that you just said like angle, length, turtle, color, theoretically later could you pass anything into and call this function?
You could, but in order to do so, what would I need to update to make that happen?
I'm not sure.
The question is, instead of, for those who couldn't hear, the question is instead of just writing these in, right? If I wanted to say a length here, I could, but I'd have to do something else too. I'd have to make an additional input up here so that that value gets passed in. It's got to come from somewhere. If it's not coming in from my inputs, then I just have to say what it is inside of the function. Those are my options, right? I don't really have many other options at this point.
So you're doing that because you're calling another function. If you like, okay, sorry, I'm just sorting it out in my head.
I guess think about it like we have listed the inputs for this function, which is the list of ingredients that this function has available to do its job. And length is not on that list. So if I need a length value, the only other option available for me to do is to just type in a number there. Right? Now, if I don't like that, if I want that value to be customizable, if I want that value to be able to change, I can do that, right? But I'm going to have to do some extra work to make that happen. Yes? Okay. Yeah. Great question. The question was, when do you know to pass in a value as an argument or to just hard code it in there, right? That's the question. It's a fantastic question. The answer is, do I expect that value to be different from one function call to the next? Or am I okay with that value being the same every single time I call that function, right? By putting the number 100 in there, we're saying we're okay with that number being the same every time we use this function. If we don't like that, if we want that number to be different every time we use a function, then a parameter is a good idea. I wish we had some more time to play around with that, but we're running a little low on time as is. Let's check this and see if it works. I'm going to call run, and then what's going to happen? Uh-oh. I didn't call my draw star. You need to do that. So we're done testing the draw line. I'm satisfied that that works. I want to draw a star, and I'll do 10 lines. 10 lines. All right, let's try it again and see what happens. Can I get down there? Oh, boy. Ooh. All right. In some universe, that looks like a star. But not this universe. Not in my opinion. So, you know, we screwed up. That's okay. These things happen. Now we get to figure out where. What kind of error is this? Semantic error, the fun kind. The program didn't crash. It did exactly what we told it to. We just told it to do the wrong thing. Happens all the time. So we have some clues, right, about what maybe went wrong. The lines, what happened? They don't intersect with each other. The turtle just picked up right where it left off. That's not what we could have that be okay. It could be okay for the turtle to pick up where it left off. We just need to be careful about how that happens, right? What would we need to do? We need to make sure that the turtle gets back to where it started after it's done drawing the line. Gets back to where it started. So I said turtle forward. I can solve this problem by also saying turtle back. Go back to where you came from, right? So that the next time you draw a line, you're at the proper starting position. Right? Let's try it. All right, here we go. Oh. Okay. Well, I mean, it's a star, right? I think we can agree that we have a star this time. However, there's another problem. I asked for 10 lines, and depending on your interpretation, I either gave you 3 or 6, right? Depending on how you see it. I don't think I gave you 10 by any definition. So what happened? Does anybody know?
But did it draw 10 times?
Did it draw? It did, but some of the lines overlapped. That's why you only see a few. So the angle. Something's up with the angle, right? Something's up with the angle. So right now it's 360 over the number of lines. And the number of lines is actually 10, which makes for a relatively easy math problem, right? I'm adding 36 degrees every single time. So we can kind of see, right? Plus 36, plus 36, plus 36, and then plus 36 got me to the same angle that I was already at before. Right? Do you see what happened there? Anybody have any ideas? Yeah. Let's try it. I mean, is it going to work? I honestly don't know, but let's try it. Let's try it and see. Sometimes guess and check is okay. Okay. Well,
Why isn't it a 12?
hang on, it's not done yet. Okay. Looks more like a tree with a branch that fell down than a star, maybe. How many lines we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
Ooh, yes, 11.
Getting warmer. Yeah.
Would you take 360 divided by lines in parentheses and then add that to the angle
So parentheses, so like this,
with 360?
with 360 instead of 180. I do think the parentheses are helpful, but maybe not for the reason that you would expect. The computer follows the order of operations, the same order of operations that you picked up in algebra class all those years ago. So this division is going to happen first no matter what, which means that the parentheses, I do think they're valuable. It helps clarify that statement, right? It makes it a little easier to understand. I don't think they actually change the outcome of this particular statement, unfortunately. Do I need one more line in the range function? Lines plus 1? How many times is this loop going to run right now? 10, and that's how many lines we want, right? Yeah, so lines plus 1, I don't think is it. Yeah.
It's turning too much because when it goes back, it's at the same angle that it already left off at. So what's happening is when it goes back, it turns a lot.
I think you nailed it. Yeah. It's going backwards. So the angle is actually changed when that happens. When I tell it to go backwards, that angle is flipped a full 180 degrees. Do you see that? Because I'm facing the opposite direction now. So how could I fix that? Add 180 every time, right? 360 over lines plus 180. Do you think that's going to work? Let's try it. Oh, where's it going to stop? It's very exciting. Oh no. Oh no. Turn the turtle 180. Ah, okay, let's try that. I did the right thing in the wrong place, maybe? Let's try it. No, that's a good idea. Turtle, oops. Turtle dot left 180. I like that suggestion. Let's see. Nope. Actually, you can see it's not rotating because we're going backwards. So something else is going on. It's not the 180. Goes backwards. Is our math off? Maybe our math's off. Go left 36 degrees. It should be 10 lines, right? Let me watch it one more time. That worked. That worked. But see, it went larger that time. I'm sorry? Yeah.
The accumulator program, what it's doing in this scenario is that it's turning the angle by 36.
Oh, I got you. Yeah. I got you. I see what's happening. This is the angle that I want to be at, but it's actually turning that full amount. That's where our wires got crossed. That's where our wires got crossed. So actually, this problem's a little simpler than I made it out to be at first, right? I don't need the accumulator pattern at all, do I? What do I need to do instead? I just need to specify how much it needs to rotate every single time. I think that gets us there. Yeah. There we go. The accumulator pattern actually was the wrong tool for the job. Is that 10 lines? Looks like it. Yep, 10 lines. Looks like it. These things happen, right? I thought the accumulator would be the right tool for the job, and it wasn't. It wasn't. I'm not ashamed. You guys told me to do it. No. Just kidding. Just kidding. That's programming. These things happen. These things happen. We eventually got there, which is a good thing. I will post this code because I know that it's different than the solution that was given to you. There are some noticeable differences between this code and the other code that was given to you, and I think that's a good thing, by the way, to have multiple versions of the same thing going on that get you the same place, or mostly the same place. Before I shut up and get out of the way, any final questions before I duck out of here? Yeah. So I could move this variable outside of the function, yes. That's called a global variable. I actually am not a huge fan of global variables. They invite certain other issues into your programs. So while technically, yes, you could do that, I think there are some important design reasons why that's not good. And unfortunately, I don't have time to go on another tangent today. But I'd be happy to talk to you about it after you break up into groups if you want to know more. I'm sorry? Local is better than global. I mean, there's always exceptions. Always. But in general, I would say yes. All right, I'm going to get out of the way so you guys can do the studio. You got a nice wagon wheel studio to do in class today. Learn from our mistakes, right? Or make the same mistake again. That's how we learn. Have a good evening, and I'll be around to see you.
Could you put that up one more second?
Sure.